So happy Thursday, guys. Please be on your best behavior today. Hopefully you are actually watching this video on Thursday during class. So today we're going to talk about how to do quadratic regression. Back in Algebra 1, you would have looked at how to do linear regression. And it's really all done in Desmos. So have Desmos standing by. So today our goal is to be able to analyze a data set to choose the appropriate regression model using technology. But again, our focus is going to be quadratic. So for the activating strategy, if you want to pause it for a moment, pause the video and answer the question first. We want to figure out for each representation, determine if a linear, quadratic, or exponential function would be the best model for the data. So you give those a try and then come back and check your answers. So for that first one, when we kind of just look at that scatter plot, those points kind of are following a linear trend. They're kind of following not a perfectly straight line, but pretty close. So this would be a linear model. And then just remember, linear equations are in that form mx plus b. I'm going to use it A just because if we were using Desmos, Desmos is going to give us a variable called a and not m for slope, but that's still pretty much slope-intercept form, mx plus b. When we look at the second model, now we have a table. You could go to Desmos and plot those points, or just focus on the y values. As you look at the y values, they start kind of decreasing as they get to 3.9, and then they start increasing. So they are decreasing, and then they are increasing. That's going to follow a quadratic model. And then from our work that we've been doing with quadratics, we hopefully kind of know that a quadratic is of the form ax squared plus bx plus c. That is on your formula sheet. And then our third one, if we kind of look at the trend, these points are kind of following an exponential model. Last semester, we learned or reviewed exponentials. You guys also covered those in algebra. Exponential equations are kind of the form a, b to the x power. So for this unit, for our class right now, we're only going to focus on the quadratic model. So we're going to learn how to go to Desmos today and come up with an equation, a quadratic equation that will best fit a scatter plot or a data set. So for example 1, the team of wildlife conservationists and marine biologists have been studying the population of pelicans in a region since 2010. The table shows the estimated number of pelicans in different years. So the first question just says, what do you notice about the data? As we look over there, again, we know that 2010 corresponds to 0, or kind of starting year, and our initial population, it looked to be 5.2 there, and then those values decrease and they increase. This is the same data set from your activating strategy. So I kind of noticed that the y values decrease and then increase. For question 2, it says describe the data distribution. That just means the shape. So if we go to Desmos, which we're going to do in just a few minutes, but just from our activating strategy, when the y values decrease and increase, it's going to follow our quadratic model. So this tells us kind of what we're going to do in Desmos in just a moment. Then for question number 3, it says using Desmos, let's create a scatter plot. So there's no need for us to do this by hand. If you want to kind of copy your graph over to the grid, you can, but since we have that technology, I'm just going to go ahead and graph it and then get ready to do the other question. So in a moment, I'm going to flip over to Desmos, but before I do that, I'm going to go ahead and scroll ahead. So I'm going to go and graph those in just a moment. And then once we get it graphed, it says, now because we know the data follows a quadratic model from the picture on Desmos and just from knowing the trend in those y values, we can use Desmos to calculate the regression equation that best models the data. Okay, we're coming up with a quadratic equation that when we graph it, is going to kind of best represent all of the points, all of our scatter plot points. And then there's a little note there that you have to remember what to type into Desmos. Super important. And so I'll kind of talk more about that when I get there to Desmos. So first, let me go ahead and plot those points so that we can see what it's going to look like. So we're on Desmos. So just a little review to graph or plot points to put in a data set. We did this back last semester a little bit. You're going to go to the plus sign, then click on table, and then carefully enter all of your values. Go back and, read them back over to make sure that you didn't make a careless typo, because then it's going to cause your values to be a little bit off. I've got all my points. I can look over here and see it's a quadratic. I've been messing around with Desmos for other things. So normally when you log into Desmos, it's going to look like that. Or you can hit your little zoom bit button, a little magnifying glass, and it'll kind of shift your graph a little bit. But I can see, yep, that's a really good quadratic model. So now what I want to do is I want to figure out that regression equation or that quadratic equation to best fit those dots. So to do this, again, you're going to use that equation that's kind of written on your notes. So you have to know like that a quadratic is y equals ax squared plus bx plus c. But then to get Desmos to give us the values for a, b, and c, we're going to type it in a special way. So you do y1, and I didn't do anything special to get that subscript. I simply typed in y1. Then you do the little tilde or squiggle, whatever you want to call it, not the equal sign. This is telling Desmos to do the regression equation. And then ax1 and then square. So do your shift button to get shift 6 to get the caret, to get the squared, and then the rest of it. bx1 and then c. So you have to have the ones after the x and the y, because if you look back at your table, our values are labeled x1 and y1. So that's when we have the ones. And then you have to have the little tilde to make sure that Desmos knows to find these numbers for you. So Desmos does the work for us once we hit the data in. And then our equation, when we go back to our notes in a minute and write it down, we're going to write down y equals. So we're just going to do it the regular way, y equals. And then replace a with what Desmos told you a was. Replace b. B is negative, so I'll do a minus. So B is 0.66, and then our C, let's do 1, 2. So I'm going to round to 2 decimal places. I think when you do your delta math tomorrow, it'll be the nearest hundredth as well. So there is our regression equation, and we can use that equation to make predictions about the pelican population. So you can kind of see on the table, we don't have data for 15 years after 2010. We don't have anything for 2025. Well, we could plug in 15 and we can make a prediction using that regression equation. So now I'll go back to our notes and we'll answer the rest of our questions. All right, so we've got our regression equation that we just used that little equation right here. So make sure you commit that to memory because it's not on a formula sheet. And then it'll give you your A, B, and C. And then now replace A, B, and C with what the actual numbers are. Then for question number 5, it says use the regression equation to answer each question. So for A, determine the y-intercept and interpret its meaning in terms of the scenario. So the y-intercept, according to my regression equation, is 5.12. And this is just what our expected value. It's the expected number of pelicans at time 0, but for this particular problem, year 0 times 0 is 2010. Now I know in our table, we actually have 5.2 listed for 2010. Again, 5.2 is the actual value 5.12 is what is expected to happen if we didn't know the actual value. Those are pretty close. So a regression equation gives us a pretty good estimate. For B, it says determine the x-intercept and interpret the meaning. Well, if we go back and look at Desmos, if you go back and click on your Desmos, there are no x-intercepts. So that just means that this pelican population will never reach zero. Population is never going to die. That's a good thing. And then C, predict the number of pelicans in the region in 2014 and 2019. So again, remember, our particular data set starts at 2010. So for 2014, we're going to do x equals 4. And for 2019, we're going to use x equals 9. And then if you're using that regression equation, you're just plugging in 4 and 9 for your x value. It would kind of look something like this. Go and plug that into Desmos. I should get about 3.9 thousand. We'll kind of go and look at that one together in just a moment. And I'll show you on Desmos how that works out. And then we would do the same thing for 9. Just replace your 4 with a 9 and calculate, again, our prediction for what we hope might happen based on our regression equation. So what I like to do, and I know you guys are savvy, you're good with this too, I'm just going to copy that equation there so that I don't retype anything in incorrectly. And then replace that x with a 4 and replace that x with a 4. That makes it a little bit faster. So we could expect there to be 3.92 thousand pelicans in 2014. And then let's do another copy and paste. I'm gonna actually copy this one this time. Paste. And then just change the 4 to a 9. So 6.47 or 6.5 for that one. Purpose of that regression equation is to make predictions for numbers that we don't have. So we're going to look at one more example, and then tomorrow you'll have a chance to practice, or you could go ahead and maybe start your Delta Math today, or catch up on any previous Delta Math that you haven't done. So example 2, this one shows the number of rabbits in a forest over time. Use a quadratic regression equation to predict the number of rabbits in the 7th year. So now I'll go back to Desmos. I'm going to type in my data. I'm going to get that regression equation. And remember, regression equation is by doing this right here. So you've got to commit this to memory. It is not on a formula sheet. You do have on the formula sheet ax squared plus bx plus c. You have that quadratic model. You just have to know to put the 1s in there and that little tilde is in there. All right, so back over to Desmos to finish this up. I'm gonna delete that one. I'm going to go ahead and do all my Desmos work at once, and then I'll go back to the notes and fill in our answers. So again, back to the plus sign, table, enter your values. I always say take a moment and just make sure you entered everything correctly, because if you mistype one number, it's not going to give you the right A, B, and C. And then I'm going to do Y1. And if I would kind of tell you, if something doesn't work, if you don't see the A, B, and C popping up, then you're just not typing it in right. You're leaving off the 1s or you're leaving off the tilde. And I'm having trouble here. Okay, there we go. And so there's my A, B, and C. So then I can use that to write down that equation. And then I'm going to go ahead. I like to type in the equation. I'm going to round again just to the nearest hundredth. So 2 decimal places. And then I'll also kind of fix the graph and talk a little bit more about that graph in just a second. So again, if you want to see a pretty picture, hit that little magnifying glass, do that zoom fit, and so I can see there were my points. And then my graph, my quadratic equation that we came up with, looks like a very good fit for all of those dots. And then now I want to make a prediction when X is 7, how many rabbits are going to be there in year 7. So I get that there would be 133 rabbits in year 7. All right, so then as we finish it up, again, we've got our regression equation that we're going to write down, and then we've got our prediction when we plug in 7. So I'm going to go back to our notes one more time and just wrap things up. Y equals 2.14x squared, 0.94x, 21.8, and when we plug that in, we got 133 rabbits. That one kind of is appropriate to round to the nearest whole number. All right, so go back and rewatch if you need to, but it's really just making sure you know how to type in that equation in Desmos and then plug in a number to make a prediction. Again, tomorrow, your assignment will be a little bit of practice. You'll do some practice in Desmos and then a little bit of practice on a worksheet as well. So please be good, do that work, keep up with things. If you have extra time today, go back and catch up on some previous Delta math assignments if they are not finished. And I will see you guys next week.